ionic equations, you need to have your solubility rules in front of you, and you should all have those in the reference section in the back of your notebook. So by the end of the presentation, you should be able to write the net ionic equation for a solution of silver hydroxide is added to a solution of lead 2 carbonate. So when we mix two aqueous solutions of ionic compounds, we get a precipitate, and that's this solid right here, this solid yellow. That would be the precipitate that's formed. And you're going to predict the precipitate based on your solubility rules. So first you have your molecular equation, which is the one that y'all have all seen. Y'all can all write these. Then what you do is you break it apart into its ions for a complete ionic equation. So KCl would break apart into potassium, chlorine, and you have to make sure you write your charges. Lead nitrate is soluble, so it would break apart. Potassium nitrate is also soluble, so it would break apart. Now if you look here, lead chloride is a solid, so that's going to be our precipitate. That is not going to break apart, so we leave that together. Okay? Only what's soluble breaks apart, and you'll have to look at your solubility rules, and you'll always have those for the test and the EOC. So once you've written your complete net ionic equation, then you cancel out any spectator ions. So spectator ions are ions that are on both sides of the equation that don't really do anything. They're just kind of there watching, like a spectator. So potassium is on both sides, so that is not really part of the reaction. And nitrate is on both sides, so that's not really part of the reaction. Then you just write what you have left over, and that becomes your net ionic equation. So let's do some practice. A solution of barium bromide, so we've got barium bromide, and it says it's a solution, so it's aqueous, reacts with a solution of sodium hydroxide, and it says it's a solution, so it's aqueous, will give me, now precipitation reactions are always double displacement, so we're just going to switch our cations, so we get barium hydroxide. Don't forget to crisscross and write your ionic compounds. If you don't know how to write ionic compounds, you better come to tutorials. It's not going away. And sodium bromide. Okay, now we're going to figure out which one of these is going to be our solid and which one is aqueous. So if you look at your solubility rules, alkali metals are always soluble. So this is aqueous. And most hydroxides are soluble except for barium. So this is our solid. Alright, now let's make sure this is balanced. And it's not, so we need 2 of these and 2 of these, and there we go. Okay, so now we're going to break these apart into ions. So we've got barium 2 plus aqueous plus this 2 right here is now going to go in front of here. We have 2 bromine minus aqueous plus 2 Na plus aqueous plus 2 OH minus aqueous yields. Okay, now this is our solid, so we're not going to break it up. We're going to leave it alone. Barium hydroxide plus 2 Na plus 2 Br minus. Oops, minus. Now we're going to cancel out our spectator ions. So I've got bromine, bromine, sodium, sodium, and then I'm just going to write what I have left over. So I've got barium 2 plus aqueous plus 2 OH aqueous yields barium hydroxide solid. Okay. Aqueous copper 2 nitrate. So copper 2 nitrate, and it says it's aqueous, so that means it's aqueous, it's soluble. Reacts with, so plus aqueous potassium carbonate, so K2CO3. Now it's always double displacement, oops, aqueous. So I'm going to swap my cations, so copper carbonate, which is going to be my solid, plus KNO3, because alkali metals and nitrates are always soluble. Okay, then I'm going to break them. Wait, I need a balance. I've got 2 and 2. I need a 2 here. Okay. Now I need to break apart my ions. So I have copper 2 plus 2NO3 minus aqueous plus 2A plus CO3 minus. I'm going to leave my copper carbonate alone because it's my solid, it's my precipitate. Potassium aqueous plus 2NO3 minus aqueous. And I cancel out my spectator ions, so I have my nitrates and my potassiums, and I write my net ionic. Copper aqueous plus weak CO minus gives copper carbonate solid. Okay. Alright. Dissolve lead to iodide. So lead to iodide reacts with, so this is dissolved, so it's aqueous, reacts with aqueous potassium chloride. It's always a double displacement, so PbCl2. Now lead chloride is not soluble. It's not soluble, so it's going to be a solid plus Ki, which is aqueous. Okay. Now the way I'm finding these out, again, is I'm just looking at my solubility rules, I'm just rating them off. It tells you this and this and this is soluble, this and this is insoluble. Okay, so are we balanced? No, 2 of these and 2 of these. Okay. Then let's break them apart into ions. So Pb2 plus aqueous plus 2I minus aqueous plus 2K plus weak aqueous plus, I'm going to run out of room, aqueous plus, whoops, yields, leave my solid alone, I'm totally running out of room, plus I, 2I minus. Okay, whatever. These are spectator ions anyway, so they'll be canceled out. And we get Pb2 plus aqueous plus 2Cl minus. Aqueous yields PbCl2 solid. Alright, if you can't answer the question at the beginning of the presentation, then go ahead and watch the practice video.